Good evening, everyone. I want to welcome you all here this evening. I'm David McLean, and I serve as the Dean of the College of Engineering here at Colorado State University. And on behalf of my colleagues, I just want to welcome you here this evening to this panel discussion. This panel discussion is in partnership with NCAR, and we're really excited to have this distinguished group of some of the leading experts in the world working on climate change able to join us here this evening. As many of you would be aware, the National Center for Atmospheric Research is a federal national lab headquartered in Boulder that provides world-leading research in Earth system sciences. CSU and the College of Engineering through the Department of Atmospheric Science and also through our Cooperative Institute for Research in the Atmosphere has a long history of partnering with NCAR on many, many successful collaborative efforts, and we're extremely grateful for that long partnership. And we're grateful for this exhibit, as you've seen perhaps before coming into the auditorium here this evening, really highlighting and providing information on the science of climate change and how it's affecting all of our lives. NCAR is managed by another acronym referred to as UCAR. UCAR is the University Consortium for Atmospheric Research. This is a nonprofit consortium of some 115 colleges and universities, and they are charged by the National Science Foundation to manage NCAR. And we're very fortunate to have the president of UCAR joining us here this evening, Tami Busalacchi. Tony has been president of UCAR since 2016. He's a nationally recognized expert on science policy related to Earth's climate systems and ocean atmospheric interactions. He's provided key testimony to Congress on the importance of this research, and he was formerly the director of the Earth System Science Interdisciplinary Center at the University of Maryland, following a 20-plus year career at NASA. Tom is a member of the National Academy of Engineering, as well as a fellow of the American Meteorological Society, the American Geophysical Union, and the American Association for the Advancement of Science. So Tony, I'd like to welcome you forward and just make a few remarks, please.
Thank you, Dean McLean. Let me get over here so I'm back to you. So first of all, my thanks to Dean McLean and the entire university here at Colorado State. It really is a great privilege to have our climate exhibit being the first sort of road trip outside Boulder. Let me first thank, where is Rebecca Hacker, the head of NCAR Education and Outreach, and John Ritzky, the head of UCAR Science Education, who were instrumental in putting this, and Lorena, back in the back as well, who was instrumental in putting this exhibit together. That is kind of the road show for the science exhibit we have at the NCAR Mesa Lab. And my favorite part of it is the climate stories. And so really pay attention to what people leave behind there. And so one of the reasons why we're here today is, of course, due to our great colleague, not former colleague, present colleague, the former director of NCAR, Jim Hurrell. And it's really great to have Jim here at the university in his professorial status and to continue this relationship here. And then one of my bosses, Dave Randall, who's one of the trustees on the UCAR Board of Trustees. And so it really was a natural to be here at Colorado State. And we appreciate the opportunity because, as you know, given what's going on in the country about pushback on science, and it's really important to get out there in the community at all different age groups, basically from K to grade, and I'm the example of the grade, of getting our science out to the public. And I think this exhibit is really illustrative of getting our message out as to why fundamental and basic research is so important and how it informs policy and how it really informs decision support. So again, it's truly our pleasure as an organization to be here with Colorado State as one of our member institutions. So again, Dean, thanks very much.
So I too will stand off here to the side just to not block the panelists. We're very excited about the panelists here, and I want to give some brief introductions. I'd like to start on your far right, the audience is far right. Emily Fischer is an associate professor in atmospheric science. Emily's research uses both field measurements and advanced modeling approaches to better understand the role of climate in determining the atmosphere's self-cleansing capacity. Next to Emily is Ellison Carter, assistant professor in civil and environmental engineering. Ellison is an expert in air quality and exposure to pollutants. Her research focuses how on energy policy and housing and transportation planning impact air pollution and human health. And next to Ellison is Russ Schumacher. He is an associate professor in atmospheric science, but he is also the climatologist for the state of Colorado. Russ's research focuses on weather analysis and forecasting and the societal impacts of extreme weather. He's a highly sought after and widely quoted source in the media on Colorado weather phenomena of all kinds. Next to Russ is Tami Bond. Tami is a Scott Presidential Chair, and she's also a professor in mechanical engineering. Tami is an internationally known researcher in energy consumption, global atmospheric chemistry, and the effects of air pollution on human health. And next to Tami is Bob Henson, meteorologist at Weather Underground. He has written 5 books on weather and climate change, including The Thinking Person's Guide to Climate Change, and one of the most widely used textbooks for college meteorology courses entitled Meteorology Today. And then next to Bob is Dave Randall, University Distinguished Professor in Atmospheric Science. Dave is an expert in the effects of clouds on energy flows and transformations, and how clouds affect temperature and the reliability of climate models. His groundbreaking characterization of clouds in global atmospheric modeling is now used in climate modeling worldwide. And lastly, I'd like to introduce Jim Hurrell as our panel moderator. As Tony mentioned, Jim was formerly the director of the National Center for Atmospheric Research. He joined CSU in 2018 as the Scott Presidential Chair and Professor in Atmospheric Science. Jim is widely regarded as one of the world's top climate experts on climate dynamics. His research centers on analysis and modeling of our climate and the risks changing weather patterns will have on many sectors of modern society. He's also provided leadership to numerous prestigious international and national programs and panels on climate variability. And with that, Jim, I'd like to turn this over to you and let you continue the discussion. Thank you.
Great, thank you very much. And I would just personally like to thank all of the panelists for taking time out of their busy schedules to answer some questions this evening. I'd also just like to acknowledge my colleagues, not former colleagues, at UCAR, at NCAR. Rebecca, thank you for reaching out to CSU and arranging for the exhibit. But especially thank the students that are here and members of the public for entering into this dialogue about climate change. So I'm the moderator. I'm going to take questions tonight and direct them toward our panelists, and this is a great opportunity to benefit from the expertise of the panelists. I do want to steal a mic for about 90 seconds. I see some of the students in my class here, so thanks students, and you know what I'm going to say. There's 5 key things that I like to communicate about climate change science, and I think these elements are emphasized in the exhibit. And those 5 key things can be expressed in only 10 words. And the credit for these 10 words goes to a colleague, Tony Leiserowitz at Yale University. It's not what I came up with, it's what Tony came up with. And so those 5 key points are: number 1, it's here. Climate change is not something that we will experience in the future. It's something that we are experiencing here today, with impacts on people, with impacts on the economy, with impacts on ecosystems. It's us. We know that the changes that we are witnessing in the climate system are beyond the range of natural climate variability, And the culprit is the astonishing rate at which greenhouse gases are accumulating in the atmosphere due to the consumption of fossil fuel and other things like changes in land use and deforestation. It's serious. We are already seeing the effects of climate change through things like increased number of record warm days compared to cold days, heavier rainfall events around the globe, droughts, and more severe wildfire events. In Colorado and the Intermountain West, we see things like the pine bark beetle kill. Number 4, scientists agree. There's a very strong scientific consensus on these topics. The U.S. National Academy of Sciences, other international scientific academies, the Intergovernmental Panel on Climate Change have all made statements that anthropogenic climate change is unequivocal. Okay? And finally, and I think very importantly, there's hope. There are things that we can do. And so where climate change, how it evolves in the future, we have some control over that. And so where we are 50 years from now, 100 years from now, very much depends on what we collectively decide to do about climate change moving into the future. So that's my opening comments. At this point, I would like to turn to the panelists. I want the key part of tonight is question and answer. Before we get to that, I've asked the panelists to make maybe 2 minutes of comments on this topic that they wish to make. So I will, I'll be a little bit random here. I'll start with Russ, okay? If you grab the microphones, they come alive when you speak into them. Otherwise, they turn off. So you can just keep holding it. So Russ.
Okay, I get to go first. So my background, as was mentioned in the introduction, is much more on the weather side, and of course there's lots of pithy quotes out there about the difference between weather and climate. You know, climate's what you expect, and weather is what you get, and things like that. But also, right, we live in a state here, in a location where the weather is highly variable. We see huge ups and downs from very hot days to very cold the next day. We're sitting, maybe 100 yards from our CSU weather station that's been there since it's been here on the CSU campus since the late 1800s, and that's one, local way that we can measure these effects. But of course, what we really need to do then is not look so much at just those, those individual statistics of your cold day or your warm day, but looking at things both locally and globally, and the signal, I think, on a global perspective is pretty clear, as Jim just laid out, of what's happening. Here locally in Colorado, of course, we're still going to have hot days and cold days. It's still going to snow in the mountains, but maybe it won't stick around as long into the spring and things like that. And so those are some of the issues we have to deal with here in Colorado, and that connects what I think is probably going to be the most important issue for Colorado's climate, and it has to do with water. Climate change is water change, and we're a headwaters state here, and our water comes not only to those of us that live here in Colorado, but many other states through many river systems, and there are already stresses on those systems, and I think that's one place where a lot of us should be paying a lot of attention to what's happening in terms of what affects us here in Colorado, not to mention the larger effects in many other places.
Great, thank you very much, Russ. How about Emily?
So after Russ speaks, then I think I should have worked on water, but I don't. I work on air pollution. So I am an atmospheric chemist, and I work on a number of topics that intersect air pollution and climate. So just to give you some examples of those types of things, wildfires are a great example. So members of my group have looked at how wildfires across the West are connected to environmental conditions in the past, and then how those environmental conditions are expected to change in the future as one way to predict future wildfires, which is of interest to this community. And then other members of my research group are looking at what's in smoke. So we're blanketed by smoke for a few weeks every summer here in Colorado. What's in that smoke? How does it change as it ages? Questions like that. We're also thinking about what it means to transition to a natural gas energy system. So what happens in that system? What leaks out along with the methane, and what does that mean when it mixes with other urban pollutants? What does that mean for ground level ozone here and across the US, and then actually you can see that hemispherically. So those are the kinds of things that I'm interested in, even though after I hear Russ speak, I should learn more about water.
Thank you, Emily. Dave.
Hi, I wrote some notes to make sure that I remembered what I wanted to say. The first thing I want to say is that the science of global warming really started about 160 years ago with a guy named John Tyndall, who was the first to measure the absorption of infrared radiation by CO2, which is key to the whole process. So I want to jump forward to the 1960s, 100 years later. I was in high school, and about that time, Charles Keeling discovered that CO2 in the atmosphere is increasing very relentlessly year to year, measurements from Hawaii. And I read a book back then in high school, a kid's science book, that said that there was a possibility that in the future, increasing CO2 caused by burning fossil fuels would actually cause our climate to warm up. And I remember thinking, wow, could that really happen? So it made an impression on me at the time. I'll also mention that NCAR was founded about that time, 1960, and CSU's Department of Atmospheric Science was founded in 1962. So skip forward to the 1970s, I was in grad school learning about atmospheric science, and that was the decade that the first fairly detailed and realistic simulations of global warming were done, using climate models on computers. And during that decade, the scientific community increased its degree of interest in this whole problem. It kind of swung up. But the popular media didn't pick it up until the 1980s. In particular, 1988 in June, Jim Henson from NASA testified before Congress and happened to coincide with a severe heat wave in Washington, D.C., so it attracted a lot of press attention. And that was really the beginning of relentless popular attention to global warming in the media. My own opinion at that time, this was about the time I came to CSU in 1988, was that the warming was probably going to happen, but I wasn't quite sure, didn't quite know what to think. But I decided that I needed to learn more about it. So during the 90s, I very deliberately taught myself more about it by reading the scientific literature and talking with people. And I was persuaded by multiple lines of evidence that this was a real thing, it was really going to happen. Not much doubt about it. And my own research group here at CSU started to simulate global warming with our climate model. So going forward then to the 2000s, this is my last bullet, measurements have shown now more and more clearly every year that the changes that were predicted during the 1970s, and some of them even before that, are really happening now in the world. We can see them, we can measure them, the predictions are coming true. And so one of the things that happened during that period as far as my own involvement is concerned is that I started to work heavily in the Intergovernmental Panel for Climate Change for about 10 years or so.
Thank you, Dave. Tami.
I was not prepared. Hi, okay, so I am an engineer, as Dean McLean mentioned, and what engineers do is we solve problems. And so I'd like to emphasize the last two words that Jim Hurrell said, there's hope. But in what way is there hope? Obviously not if we sit around and complain about how it's such a big problem and we can't do anything about it and it's too big.
let me ask you a question. As an engineer, how many of you would let the runoff from your toilet run into your backyard? Right? So that's basically what we're doing with combustion. We're letting the waste product of combustion go into our backyard, and then it mixes into the atmosphere. And letting your toilet run into your backyard was something that we did many hundreds of years ago, and then we realized that it was making us sick, and we developed big infrastructure and sewer systems and treatment plants and so on to deal with it, because we don't want to live in our waste. Well, that's the point where we are at now with combustion for energy. And there are things that we can do. We can replace the combustion with different energy sources, and I think everyone's familiar with solar and wind, and possibly taking carbon out of the exhaust and storing it in the ground. So there are some big systems. There are lifestyle changes that are mentioned in the exhibit outside. But the thing I want you all to leave with is a thing that I learned from being not in a mechanical department where I am now, but a civil engineering department where I was for many years before I came here. And that is that people can do big things. And so the changes that you make in your own life, buying the hybrid car and switching your diet, those are important. The things that you choose are important. But the things that society enables us to do are also important. In order to deal with this problem, we're going to need to think big. We're going to need to allow ourselves to think big, not be afraid of thinking big. Imagine if you could re-envision the transportation system. Would you have the one that we have now? What would you do? Right? So let yourself re-envision. Don't be afraid of that. And I think climate change, all of this is true, but the fact that we can no longer live in our own waste is giving us a signal that it is okay to think bigger.
Thank you very much. And we're already getting a number of really great questions, so we're going to wrap up. We have two more panelists. Ellison, would you mind making some comments?
Sure, thank you. So I'm in Civil and Environmental Engineering department here, and I largely focus on variability in air pollution exposure and how we get exposed and what drives disparities in those exposures. And so where I think my work collides most with climate change is in thinking about household energy. So on one end of the spectrum, work that I do looks at household energy that's from solid fuels and how replacing those with cleaner sources can lower exposures and improve health, but what is a side benefit or a co-benefit with that might be climate change impacts as well. Sort of bringing that closer to home, work that I've been doing with the city of Fort Collins here is also looking at reducing household energy use, but focused on energy efficiency. So there are those in my group that are now looking at how energy efficiency programs here can benefit people in terms of their air pollution exposure while also serving the climate action plan that Fort Collins has in place. And then I'd say the other way in which the work that I focus on collides with climate changes is in terms of how climate change is going to affect spatial distributions of risk. People who are affected in their homes now might be less affected in the future, or they might be more affected in the future, and a lot of the work that I do is driven by a desire to help those that are the most at risk or might be the most at risk in the future because of climate change impacts on their flooding risk to their home or fire risk to their home, and how that would impact their environmental exposures.
Great, thank you, Ellison. And last but certainly not least, Bob.
Thanks, Jim. It's hard to know how to follow all of you all. It's all fantastic. So I'm a hybrid meteorologist and journalist, and my interest in climate change stems from both of those. I came to Boulder in the late 1980s and was fortunate enough to land a job at NCAR, where I was able to write about weather and climate and learned a tremendous amount about climate change, an incalculable amount from all the people who were there, including Jim himself. So that's really what got me into this topic. I grew up in Oklahoma, which is a very weather-savvy state, but has struggled a lot with climate-related issues. So I actually have done talks in Oklahoma, and that's been a fascinating experience. I actually love talking to all kinds of groups about this topic. As a communicator, I think in recent years my interest and concern has been multifold. I've been really heartened to see how more and more people are taking this issue more and more seriously. I mean, That's a huge advance. I think it's probably being taken more seriously on average by the public than ever before, and I'm really heartened and gratified about that. What concerns me and worries me a little is that I think maybe too many folks are already thinking game over. Like, it's too late, you know. We're killing the earth. There's no way we're going to recover from this. There's nothing we can really do. And I think that's falling into the polarized thinking that so dominates our culture right now. And in fact, Kate Marvel, who is a wonderful scientist, climate scientist and communicator at NASA, has put it this way. She said, climate change isn't a cliff we fall off, it's a slope we slide down. And I think, you know, despite the fact that there are real deadlines that we need to set for ourselves, and 2030 is a year you've heard often cited as a deadline, nothing magic is going to happen in the year 2030 or 2031. The more we do, the better off we'll be. And the more each of us does, the better off we'll be. And so I encourage you all to be as optimistic as you can. I consider myself a worried optimist. I'm optimistic in terms of all the things that can be done, that we can do as individuals, as citizens, as consumers, as voters, as students. So that gives me hope. I'm concerned that we won't do as much as we need to do. And I think that's still a real possibility. So we have to keep positive, chin up, keep calm and carry on, as they said in Britain during the Blitz in World War II. I'm sure many of you have seen those posters. And I think this is going to be, it's a hellaciously complicated problem that will be with us all our lives. So the thing to do is not turn off to it or be fatalistic, but be smart and be active and take it seriously.
Great. Thank you all for those opening comments. So the rest of this session is very much going to be question and answer. We can do this two ways. Follow the instructions that are up on the screen, and I think I've already received about 9 questions. Or if you have a burning question, you want to raise your hand, we'll get a microphone to you. You need to speak into the microphone because this is being recorded. So we're going to start off. One of the questions that came in a little bit in advance was by Lindsay X, who's the climate program manager here for the city of Fort Collins. And she had a question that was, if policymakers knew only one thing, what do you wish they knew about this field or this topic? And I'm gonna let any of the panelists that want to answer this answer it, but to get the ball rolling, I'm gonna go right back to Bob.
Okay, I'm going to take a page from Russ and say I wish policymakers knew that really water issues are probably more important than temperature issues in terms of how we adapt to society. Society adapts to climate change. To me, the most striking finding in the last few years that we didn't quite expect is the hot drought phenomenon. And this has driven forest fires in California, and fires in Africa, South America, and most recently in Australia. The idea is you don't have to get droughts to get any worse, right? If it's not raining, it's hard for it to not rain harder, right? Because you have zero. So there's only a certain limit to how bad a drought can be in that sense, but it can get hotter. There's no limit to how warm it can get. So what we've seen in recent years is places that have drought-prone climates, those droughts are getting hotter, and that heat is sucking more moisture out of the landscape, drying out the landscape for longer periods and more intensely. And so that seems to have really fueled the wildfire outbreaks in many parts of the world. So I hope policymakers in general will take not just that, but many other water-related issues really, really seriously.
Anyone else want to add to that? Okay, you are truly an awesome audience. These are some of the best questions that I've seen in these kind of settings, so I want to try to get through all of these. By the way, my 17-year-old daughter would be so proud that Dad's actually using technology. She wouldn't believe this. So the first question, and if you want to identify yourselves by raising your hand, that's fine. We have a question. Do individual actions like recycling and taking shorter showers, not buying plastic, do those things really matter? I keep hearing that it's industry that has the largest impact on climate. What is the best thing I could be doing on the individual level? You want to raise a hand, whoever sent that in? You don't have to. Okay, no hands. Anonymous question. Who would like to answer that? What's the best thing to do as an individual?
I can say something.
Please, Tami.
the best thing you can do on an individual level is vote for somebody who's going to make a difference. The second best thing that you can do on an individual level is to become scientifically aware and run for office. Or be scientifically aware and run for office. I think that everybody should engage in those items of personal responsibility and pay attention to what we're doing, because it is our lifestyles that are not just casting away things in the garbage, but also buying things from the very industry that we're blaming for the problem and asking trucks to deliver them to us. And so we're pulling on those strings. And we should be aware of those things, and even the act of using a cloth bag reminds us every day that it's the little things we do that add up. But our footprint is so much bigger than the things we see every day. We need to have a societal-wide conversation about where we get energy, where we get products, and turn those into much lower impact. And you cannot do that as an individual. You have to do it as a society.
Great, thank you, Tami. We have several questions sort of along this theme, so rather than seeing if another panelist wants to take it since time's limited, let me ask this. We have a question. What can students do to help climate change?
Such a
Ellison.
good question, but I'm struggling for an answer. I don't know that I would want to pin an answer on any one response. I think right now I'm currently teaching 2 classes, one at an undergraduate level, juniors and seniors, an air quality engineering class. So I'm thinking about what I talk about with them, and I think, like Tami said earlier, I want them to think really big. Most of them came into the civil and environmental engineering program and didn't even know they would have to take an air quality class, frankly. And so it's a big surprise to them to be in that class, and I want them to think about how they as engineers can take a problem-solving mindset to any profession that they choose, whether that's serving in local government, running for office, working at a consulting firm, working abroad, and I think that mindset is one you can bring to climate change, which is that you as an individual can contribute to a very big, a big body of people who want to solve a big problem that can't be solved by an individual. So that's not a very great answer, but I want them to think big, and I want them to view themselves as part of the big solutions that need to be developed in order to address climate change.
Can I add one thing? I would say that as a student, it's you should not assume that you don't have something to contribute, because clearly the people in charge right now are not doing a good job. And but that's true, right? This is a huge problem, and so you should go at it full force. And I think actually the more personal changes you make, the better you understand the problem and how hard it will be to solve. So, for example, my family's trying to figure out how to go carbon neutral. Not easy, right? So I have to go down in the basement and figure out if my radon thing is working, so and how much energy it's pulling. So I think that you can both gain from the personal efforts, because you might have a deeper understanding of the bigger problem, and then it might motivate you to engage on a larger scale.
I see a couple of questions in the audience. Lauren, while you're taking the microphone to one of the people with their hands up, let me read this one. What improvements are needed to reduce uncertainty in climate model projections? Dave?
We're all looking at Dave.
Well, I think, first of all, let me say the biggest source of uncertainty about what's going to happen is that we don't know what people are going to do in the coming centuries. Right? So climate change depends very much on how much we burn and various other things that we do. That's the biggest source of uncertainty. But in terms of, and some people are actually trying to put human decision-making into the models. This is at a very early stage. It makes me a bit nervous. You know, we can't predict war and peace, we can't predict technological change, we can't predict what the economy is going to do, or we're going to predict emissions. I don't know. Anyway, in terms of what's in the models now that contributes a lot of uncertainty, I think the The two big things are clouds, which is one of the things that I work on. We're getting better. There's a lot of progress with that, but there's still significant uncertainties. There's been some work recently that suggests that there could be big changes in low clouds like the ones that are off the California coast in the summer. Some of you will know about that. That might lead to a significant increase in warming in the future, but we don't know if that's right or not. It's being explored. The second major area of uncertainty in the current models is carbon feedbacks. So how is the vegetation going to change? What's going to happen to the permafrost? What's going to happen to the carbon in lakes and the ocean? You know, if a lot of carbon comes out into the atmosphere, that will obviously tend to increase the warming, but we don't have a good handle yet on how strong that effect is going to be. So that's a major source of uncertainty.
Thank you. My name is Corey Carroll. I'm actually a family doc here in Fort Collins. And one comment, I heard diet. I would agree that's a good thing to do for your own health and for the planet, which is eat more plants, less meat. But Scott Dannon gave many lectures that I was fortunate enough to attend, and a couple things he brought up were that we made some amazing changes in this country over the years. Indoor plumbing was argued as a valuable thing, took a lot of money. Interstate highway, the electric grid. I would argue we need economists on the panel because those infrastructure changes didn't have an industry that was saying, I don't want you to change the status quo. We now have an industry that is extremely powerful and doesn't want to change the flow of money, which I think is the biggest dilemma. And as we're seeing potentially new economic gains, we can't actually achieve that if there is this resistance, this roadblock. So question would be, how do we get the economic model of the benefits of moving away from the status quo into the renewable, into the other areas, which would prove, I think, beneficial for the climate change, but also, I think, an improvement for our economy.
This is, I think, a partial answer. I was just sitting here thinking about it. One of the things that, especially those of us who can see retirement on the distant horizon or near horizon, anyone who has a retirement account, anyone who's saving for later in life, that account is probably, some of it is in stocks. And if you can figure out through your plan what stocks can be low carbon or no carbon, that's an immediate way you can snap your finger and in 5 minutes have an impact on the system that finances fossil fuels. You know, those companies, if they're going to survive, are going to have to figure out other ways to make money in the long run. We have 5 times more, fossil fuels than we can burn and maintain a roughly stable climate. So I would encourage everyone who has the ability within their plans to consider that. If you're a student, you might consider asking whatever university you're at to consider divesting what they can from fossil fuels. And I'm not making a CSU recommendation. I have no dog in this fight, but I do think that this is something students at a number of campuses are looking at. And you know, it's a major industry, and this is the great economic quandary we face. And there's lots of different ways to nibble at the apple, including individual changes. But certainly that's the tough economic nut to crack.
I'd like to add, from the housing perspective, because I've had the fortune of working with a couple of city programs, and I don't know if this will directly relate. It doesn't quantify transitions to renewables, but one thing that the city is interested in doing is understanding the benefits that are aligned with the utility cost reduction that you get from energy efficiency works projects on homes. So if you seal up a home and you make it more energy efficient, then the user, assuming that they don't use, that they weren't suppressing their energy use, should see a reduction in their utility bill. That's quantifiable, and that's what people are usually looking for. But if we can demonstrate with the work that we're doing that air pollution exposures are lower and people maybe use emergency rooms less for managing asthma, that's a number that people are trying to get at. There have been other projects around the United States that are trying to get at that number. so that health insurance companies may invest in a weatherization type program because they would see co-benefits on the asthma management side. And that's real, that's happening right now. And in fact, there's already a precedence for health insurance companies investing quite heavily in moving people from homelessness to being housed because they see that benefit. They're not paying for the emergency room anymore, but now they're trying to move beyond just being housed to what if you were housed in a healthy home? How much money are we saving in the emergency room mostly? And so that's, I think, an example where it's a very much a downstream effect of something that does actually also relate to reducing energy use or reducing use of fossil fuels for energy in society.
Great, thank you very much. Another good question here. What future technologies do you think will be key to help address climate change? Tami?
I don't have an answer. Future technologies like they don't exist right now? Can I clarify the question?
You want to? Okay, clarify. You can come up here, the mic's closest up here.
You can come up.
Okay, so, well, just to begin, you could perhaps give us an idea of what technologies are there to address climate change or the issues related to climate change. And two, climate change is a pretty diverse, I guess, issue. It stems from a lot of things. It stems from growing populations, it stems from energy needs, it stems from water needs. So I guess my question is just sort of focused on, one, how do we address these growing concerns that will come in the future, you know, exponential increases in population, how do we address that, and what technologies would you suggest putting towards that to address climate change?
Okay, I'm going to give you 3 answers, none of them satisfactory. The first one is obviously there are current efforts to replace energy supply with sources that originate with the sun, whether it's solar panels or wind. And those are beneficial because they produce electricity, and already a lot of our demand is in electricity. So that's one thing. And because those have gotten more cost effective, many people are putting in much more capacity. Along with those, of course, we need to work on storage of that electricity because the sun doesn't shine or the wind doesn't blow at the same time that we want to use the electricity. So that's a current area of active research. The second thing I would say is that we need to think systematically, and this is not a technology. This is a bit dangerous because people want technologies. They want widgets they can buy. Those are attractive. But when you think about we're living in the wrong place compared to what we want to do, that's a system question. And so we need to be thinking about where we're placed, how we can use less energy or fossil fuel to get there. But some of that, like is teleworking, is that a technology? So that kind of rethinking of how we interact and work is the second thing that I would suggest. The last thing, and this is not a technology either, but a systematic thinking, I think people have alluded to the fact that the impacts of climate change are disparate, and those who are lower income tend to suffer more, like with most things. And so another systematic rethink we need to do is we don't just need technologies, because those tend to benefit people who can afford them, but how will we match those solutions and the reduction of vulnerability in a societally acceptable way to the people who are hurt the most? So I didn't give you a tech answer, except for the first one.
Yeah, that's fine.
Great, thank you. I wanted to read this one. I'm not sure I want to have children because it feels unfair to bring children into this world. Can we really reverse the damage that we have done? Lighthearted question for small answer.
I'll go with that. The second part is, yes, partially. You know, we can keep climate from getting worse to a certain extent. You know, the less we emit in terms of fossil fuels, the more or the less climate will change going forward. You know, we're not there yet. Climate change is happening. It's going to get worse, but it could get a lot worse or not as worse. You know, there's a spectrum, and I think that's really, really important to keep in mind. So, yeah, that's all I'll say on that. Just that, you know, and I think as far as having kids, I don't have kids myself, and at times I've gone to such rationalizations of saying, why don't I have kids so I can take that flight to Europe? I recognize what I'm doing. So we all, you know, kids have economic and societal value beyond their carbon emissions, to put it not too fine a point.
Anyone else want to tackle having children? No? Okay, we have a question up here. Okay, I see a couple of questions, so if we could get a microphone to them. In the meantime, here's a question. I've heard the city of Fort Collins has a set of ambitious goals, I assume climate action goals. How are we working with the city or other cities to help communities achieve such goals, for instance, in climate action plans? So just at an individual level, maybe.
I can speak to the program that I alluded to earlier just briefly, and maybe give somebody else a chance to think of a response in the meantime. The program that I referenced is called Efficiency Works. It's been around for quite some time in Fort Collins, and the goal is to improve energy efficiency of housing. It's largely been a self-selected program, so targeting people who are able to pay for the projects that would happen in their home to reduce energy use. That program is very mature. It's the belle of the ball at some of the conferences around the United States. It's run really well, and so it's attracted some funding from the Bloomberg Foundation to try and address low-income housing in Fort Collins. And that's attracted the attention of the Colorado Energy Office, which would like to see that program and the expansion of that program replicated in other Colorado cities. One of the drivers of many of that program is a reduction in energy use that would serve the climate action plan. And I don't work for the city, so I see some people that I work with from the city. If I messed anything up, please feel free to speak up or correct me.
Okay.
I don't know the answer.
Here's one you probably do, Emily. I'm sorry. We'll go to your question next. Is that? Oh, one back in the back. That's where my. Please, sir.
Yeah, CSU has its roots in agriculture, and so with regard to carbon sequestration and agricultural practices, where do you see the largest benefits that we can obtain through changing some of our agricultural practices?
It's not something I have specific expertise on, and maybe there are some folks here in the room who do, but I completely agree with your assessment there, and I think in a lot of ways also the agricultural community sees themselves being maybe they see themselves being unnecessarily blamed for emissions, but I think they're also increasingly seeing themselves as a very important source of solutions to this, where people are starting to think about what changes can be made, and it comes back to the question about economics earlier: is how can that change? Then farming is very hard work, and in many cases not lucrative, and so how can all of these things come together to make changing agricultural practices that may also benefit the climate also then be of benefit to that farmer or to that landowner or whatever the case might be. I'm not that familiar with kind of all the ins and outs of the which methods work best and things like that. There are other people at CSU here that work on that, but maybe not here in the engineering college so much.
I'm going to read a question we have. I know you had your hand up as well, right? First and then over here. Maybe this came from our department head of atmospheric science, Jeff Collett, in the back there.
No, it didn't.
No, it didn't. The Colorado Front Range is a non-attainment area for ozone. What impact does fossil fuel drilling in northern Colorado have on our local air pollution problem?
Hi. So we are a non-attainment area for ozone, and just to put that, so that means we don't meet a health-based standard for ozone. So ozone is a respiratory irritant, and what's tricky about it is it's a secondary pollutant, so it's not emitted directly. It forms when two different types of pollutants mix under sunny conditions, of which we have many here in summer. So we just moved to, yes, so for a long time we've been non-attainment. And so I live in the Front Range, and I'm really realizing how bad the air is here as I live here longer and longer. So, our area just got moved to Sirius. I think we just moved to Sirius, and that puts us in the realm of Southern California. Like those are our friends in terms of the severity of the air pollution issue here in summer. And so I don't think Colorado wants to be known for its bad air. That doesn't seem to jive with the values that I see. I'm not native to Colorado. So anyway, so yes, so we are non-attainment, so that means that during summer, ozone gets to levels that are harmful to health, and it's a respiratory irritant. So the folks who are most vulnerable are children, elderly, asthmatics, people with other compromised respiratory systems. Okay, so there are multiple ingredients for ozone, and so you need nitrogen oxides. Those are typically emitted from combustion, so you can get them from burning fossil fuels, you can get them from other types of biomass burning. Lightning is a source, you get emissions from soils. But primarily in our area, we have a lot of cars. And then you need this other set of compounds called volatile organic compounds, and those are, in our area, a lot of them come from the oil and gas industry. That is true. And so those two combine, and you make ozone. There's other sources of VOCs in addition to the oil and gas industry here, but it's true that that is a large source in our area, and we're different than other places because here we don't have a lot of biogenic emissions from trees. There's not nearly as many trees as there are in other parts of the US where you might have different sources, and there's a lot of oil and gas development here. So it's a disproportionate impact here compared to probably other urban areas. Does that answer that? Whoever asked that question? Yeah. Okay, cool.
Great, thank you. Yeah, let's go to some questions from the audience.
Thanks. So Cassie Archuleta with City of Fort Collins. So I wanted to go back to that comment about kids, basically. Should have kids, or is that carbon impact of that kid outweighed by their societal contributions? But I'm kind of inspired by what young folks are doing right now, like taking my daughter to see Greta, I won't say her name right, Thunberg. And I'm wondering, how do we capitalize on that energy well? So we certainly all want to teach the children well, but how do we get them more focused and influencing what's happening at policy levels? There's just so much energy right now.
Wants to take that? Emily?
I feel like I'm talking too much, but I hear you. My second grader learned about climate change and came home crying, and I was like, that's the right response. That's the right response. I will work on it with you, right? And so I think that it's good. It is good to engage them, and I think it's really important for us to engage them because it puts things in perspective very quickly as to what the most important problems are. So I agree with you. I don't know how to do it exactly, but I think My second grader also asked me why she couldn't vote yet.
I would say the kids are teaching us, actually. I'm just amazed at the energy of the last year or two. I'm reminded when I was a child and awareness was growing of smoking, the Surgeon General report first came out saying smoking causes lung cancer. And I remember talking to my parents about it. My dad and mom were both heavy smokers. And I think that was sort of analogous to what's happening now with climate change and kids going to their parents and saying, this is a problem. And maybe why are we driving this car? Or why are we doing X or Y? So I think that's a tremendous moving forward. And the irony is that some of the same people who are dissing the science on tobacco have been involved in dissing climate change science. So there's more than one analogs there. Great.
Did your parents quit?
Sadly, my dad died of lung cancer at age 57, so this is an issue dear to my heart. And I just take that as energy and going forward,
Yes, please, Tami.
So I want to speak here as an educator, which many of us are, all of us are in some way, but as an educator in the College of Engineering, that I think that we need to tool our education for not the problem of climate change, but the problem of global changes in different ways. I was going to say kids, but students entering our programs need to be taught in the fundamentals. That's never going to go away. But we also need to give them the tools to speak, to be active, or to allow them to be active politically. And as Ellison mentioned, to take that fundamental problem solving and say, okay, now that you have the tools, what are you going to do with it? It doesn't have to be what the generation before you did. And so the people who are old, like me, teaching as professors, should have a certain amount of, this is the way the fundamentals work, and then back off and allow them maybe chances to design projects that are not traditional. And we hope to work with you at the city.
Thank you. We're just about out of time. Does someone have a pressing question that they haven't submitted they really want to ask? Okay, I'm going to give you the last question, and then I have an announcement to make if your question has not yet been answered.
Sorry about this. This is really more of a comment than anything else. The person was asked what can the agriculture industry do? I grew up in farm country, and I believe the farm country folks converted to low-till agriculture 15 years ago or so. So I think they're already there. Please correct me if I'm wrong. And then another comment on the ozone challenge. What if Fort Collins had 90% all-electric cars? Would that help? Would it make it go away?
I don't know the relative amount of ozone that's formed in Fort Collins versus regionally in the Front Range on a summer producing ozone day, which is why I'm hesitating. So I don't know. I think we could figure that out probably, but I don't know the answer to that. Certainly, if the whole Front Range decided to have electric vehicles, it would be enough of a change in that. These changes are nonlinear, so it would be enough of a change to move probably to a drastic change in ozone, is my guess. I don't know what the relative amount of Fort Collins versus the rest of the Front Range is for NOx emissions.
This is assuming that the energy to power those cars came from renewable energy, right?
Well, that went fast. It is 7 o'clock. I want to honor the schedule that we put in place because I know people have plans and other activities. And I know Tony Busalacchi is flying to Brazil in the morning, so I'm sure. So I do want to say that the panelists very kindly agreed to stick around for about another half hour. So if you have questions, or you've posed a question that has not been addressed, and we have about 26 questions on my phone that we haven't gotten to. I would encourage you to come down. You've had an introduction to the expertise of the panelists, and please feel free to come on down and ask them questions specifically. So with that, I'd just like to thank you again for attending tonight. I'd like to thank UCAR, NCAR, and CSU for working together to have this wonderful climate exhibit. And I'd really like to thank all the panelists again for taking the time to engage. I think one of the most important things we can do is to talk and to answer questions. And we know a lot, but there's some things we don't know that well yet. And I think it's very important to have those conversations. So thank you all very, very much for what I think has really been a very enjoyable evening. And with that, we'll conclude.